Hello and welcome to lesson number 2 for module 12. So in module 12 on IPv6 addressing, lesson 2, we look at section 12.4, 5 and 6, and we talk about global unicast address and link local address static config, how it is how these two addresses are manually configured, and also we talk about dynamic addressing for IPv6 GUA, how to configure global unicast addresses dynamically. And the last section, 12.6, we look at configuring link local addresses dynamically. So keep these two things in mind when it comes to IPv6 address configuration. There are two methods. We can either do assign IP addresses manually or statically, and we can assign them dynamically. And there are two addresses that are important. We have the GUA, or the global unicast address, and we have the link local address. Okay, so let's have a look at link local GUA address and link local address and how they are configured statically or manually. Now, most IPv6 configuration and verification commands in the Cisco iOS are all similar to their IPv6 counterparts. For instance, if you look at this, if we were to configure an IP address for this particular interface G000, normally in IPv4 we would type IP address. Okay, so with IPv6, all we're adding is just the v6, okay, to indicate that that's version 6. Okay, so that's the only difference, the use of IPv6 in place of IP within the commands. Okay, in many of the cases, that will be the main difference. The rest of the configuration commands will typically be the same. So in terms of when you're configuring IPv6 GUA address on an interface, you have this command IPv6 address, and then you type the 128-bit long address, okay, in hexadecimal format, and then you put the subnet mask in IPv6 known as the prefix length. Okay, so here's a good example: IPv6 address, and then your address and your prefix length. Okay, no space. Okay, no space in between. Okay, so let's take a look at one example here. Okay, so this is your activity 12.6.6. Once you open this packet tracer file up, you will notice that one of the first things we need to do is configure IPv6 addressing on the router. Okay, so we go to R1, we open the command line interface. You can just go straight, click on R1, go direct to the command line. First thing we'll have to do is EN, or enable, to go into the privileged exec mode, and we want to configure before we go ahead and configure IPv6 addressing, we need to ensure that we enable the router to forward IPv6 packets. So every time you're configuring IPv6 addressing, you need to ensure that you must enable IPv6. Okay, as soon as you type IPv6, leave a space. I encourage you to use get used to the use of the question mark. It's a context sensitive help. Okay, so this is what we need to do first: enable unicast routing. Okay, so we allow, okay, I use the tab key to complete the rest, unicast routing, to allow the router to forward IPv6 packets. Okay, so once that's done, now I need to configure an IP address on the interface G00. Okay, so I go to the interface IPv6 address, and for this case I'm going to use 200 DB 2001. So notice the 2001, this is a global unicast address. Okay, it's a global unicast address, DB811. So I'm going to configure it with this address here. Okay, DB811. You can notice with the double double colons. This is all contiguous zeros and the prefix length. Okay, so once that's done, the next address we need to configure. Once you configure a global unicast address, okay, you can always configure a link local address, but that's the key thing I wanted to demonstrate at this stage, that you can configure a global unicast address on a router, on an interface, on a printer, router interface, on a printer, on a switch, on an end device. Okay. In the event you're configuring it on a router, this is the commands you use. Okay, that's the basic command you use. Now let's have a look at the next on a Windows host. Okay, if we're configuring this on a Windows host, again, if we go to our packet tracer file, I'm going to use this to demonstrate that. So I just configured the GUI only. I'll leave out the link local address, and then I'll go no shut. Okay, so I'll leave that as it is. Let's say we want to configure a global unicast address on the sales computer. Okay, so we click on sales, we'll go to the IP config, and notice we have, okay, by the way, if I can just bring this up a bit. Okay, as soon as I go to the IP configuration, you can observe that we have IPv6 address here. Okay, IPv6 config. Okay, we can assign the prefix. Okay, so this will be a global unicast. We have the device itself automatically generating a link local address or LLA. Okay, and then you can add the gateway or DNS IPv6 information in here. Okay, so that's how you do that in a PC. But this is a packet tracer. Let's try if we can do this on an actual device. So I'll go to Ethernet, change adapter settings. Okay, assuming this is my network connection, go IPv6 properties. Okay, there you can see it. Okay, so if I click on use the following address, I can put in 2001 db8 1 and prefix will be 64. Okay, oops, 64, and close that. Okay, so I can of course remove that. So that's basically how you assign a global unicast address to a host machine. You can do that on a router by using this set of config commands. You can even do this on a Windows host, okay, by going to the adapter settings and then selecting IPv6. Okay, make sure when you are going to adapter settings, you will have two separate. If you go, there's IPv4, there's also IPv6. So you select IPv6, make sure it's enabled. Click on properties, and then you can start assigning IP address to the LAN or to the network interface card. Okay, so this is all about manually configuring the IPv6 address on a host. Okay, and it's similar, the whole process is similar to what we would do with an IPv4 address. So the GUI or LLA of the router interface can be used as a default gateway, but best practice is to always use the LLA. Now, do note here that this is something we will cover extensively in CCNA 2, but when DHCP version 6 or Slack is used, normally the LLA of the router will be automatically specified as the default gateway address. Okay, so you can either do manual configuration and allow for the device to do its own auto address configuration, that's known as Slack. Okay, stateless auto address configuration, and then you have a DHCP enabled server assigning IP addresses rather than a device being manually configured. Okay, so the next part is that's configuring GUI on a router interface. It's the same on a switch, and then you saw how you can assign a GUI on a Windows host, and it's the same concept applies to other devices and devices. Okay, so let's look at the static config of a link local unicast address, okay, LLA. Now, configuring the LLA manually lets you create an address that is recognizable and easier to remember. Now, again, think back to lesson number 1. GUAs typically begin off with the 2000 range, okay, 200 range. Link local addresses, LLAs, begin with the FE80, okay, FE80. Anytime you see FE80, those are typically LLAs, okay. And global unicast addresses, they are the 2000 range, okay. That's the first hextech. So LLAs, similar to GUA, can be manually configured, although slightly different. Let's go back to R1. Okay, so we still notice I'm still inside this interface in G00. Okay, so I can go ahead and type IPv6. Just put a question mark there. Okay, and put in the address. Okay, so IPv6 address, question mark again to leave us to see what parameters come next. Okay, so we are doing this manually. Okay, so we go FE80 and 1. Okay, now leave a space, put question mark, and there's another parameter that we need to add in. Okay, that's the link local. So this specifies that this is used as a link local address. Okay, so link local, and hit enter. Okay, just no shut again to ensure. Okay, so that means that if we do a show IP int brief, we should be able to observe that interface G01. Oops, which one was that? Yes, interface G01. Okay, or G00, that is. Interface should be up and running. Okay, so that's all good. Okay, so let's configure in a link local address. Okay, IPv6, same command, IPv6 address. This time you put in the LLA address followed by the parameter link local. So the same LLA can be configured on each link as long as it is unique on that link. Remember, link local. Okay, so it's uniquely local to that particular link. So common practice is to create a different LLA on each interface of the router to make it easy to identify the router and the specific each specific interfaces. Okay, so in that first section of this lesson, we talked about how you can manually configure link local address and global unicast address on a router. Same applies to a switch, what commands to use, and you can also follow the same process. Applying it to a host or configuring the address on a host is straightforward. Go to the network interface card, go properties IPv6, and you assign a link local address, a global unicast address. Normally when you look at the IPv6 configs, it will automatically generate a link local address. Okay, how do we know? We can do go to CMD. Okay, you can go to CMD and just do a ipconfig all. Okay, so if I go somewhere down to my wireless LAN adapter, okay, notice that this network is already enabled to support IPv6, and it automatically generated its own link local address. Okay, notice the FE80 in the front. Okay, that's a link local address. It automatically generated that address. Okay, so we don't need to do that. Only for the global unicast address, we go to adapter options or settings, we select IPv6, and we assign the GUA address. Otherwise, LLA, it's automatically generated. Okay, so the next point is dynamic addressing for IPv6 GUA. So we just talked about manual static configuration. Let's look at dynamic addressing. Okay, so with dynamic addressing for IPv6 global unicast addresses, there are two concepts you need to understand. With dynamic addressing, that means that there is a there is a device that's responsible for leasing out addresses that acts as a DHCP server, okay, much like a DHCP server in an IP version 4 network. And then you have the DHCP clients. Now they typically pick up IP addresses from the server. Okay, so you have a server in place. This can be a router that's DHCP version 6 enabled, or it can even be a Windows or Linux server that's configured to function as a DHCP version 6 enabled server. So these DHCP version 6 servers will lease out addresses to client devices. Now what we're trying to understand here is how is it possible for IPv6 enabled client devices to dynamically pick up an IP address from a server. The key concept here is this: it all depends on two things: router solicitation messages, RS messages, and router advertisement messages, RE messages. Two types of messages are used, okay, RS and RE messages. So for end devices, okay, for any device that's configured to act as a DHCP client, it will obtain global unicast addresses dynamically through the ICMP v6 messages. Okay, so much like IPv4 networks, okay, you have the ICMP messages. Remember the ARP address resolution protocol? Host devices will send out a broadcast, okay, querying or asking for IP addresses, and then DHCP enabled devices are going to respond. Okay, so normally this process is in IPv4 DHCP, it's known as DORA. Okay, discover, offer, request, okay, and accept. Okay, so DORA. So with router solicitation messages, they are sent by host devices. By the way, this word solicit, okay, that's ask. Okay, that's another word for ask, which means that clients, okay, let's say this is a client device here. This client will send a router solicitation message, okay. As a host device, as a client, it's going to send an RS message, okay, looking for IPv6 enabled router. So assuming that this is an IPv6 enabled router, this router also on the other hand is going to periodically advertise, okay, send out array messages known as router advertisement, array messages, to inform host on that network, that particular network which this router is a part of, will inform them on how to obtain an IPv6 GUA and also provide other useful network information. Now these array messages will contain three types of flags, okay. They will contain three types of flags, okay, so an M flag, an A flag, and an O flag. Okay, so there's a separate video I put up, the link, where I explain this, the different flags. Okay, so that's how these router advertisements will inform hosts within that network how they're able to obtain an IPv6 address. Okay, so two types of messages are used. Remember, if IPv6 addresses are going to be allocated dynamically, that's router solicitation, which basically means host devices solicit or they query or they ask using these RS messages to find out if there are any IPv6 routers or servers available. On the other hand, those IPv6 DHCP version 6 servers also send out router advertisements. Not just DHCP version 6 servers, any IPv6 enabled router will use array messages, so will send out array messages periodically. Okay, so what's contained within those messages? Network prefix, prefix length, sometimes default gateway address, DNS address, or the domain name including also. Okay, so there are three methods that the array messages can use to provide these IPv6 global unicast addresses. Remember I mentioned flags. Well, leave those flags first and let's look at the methods. Okay, so the first method is SLAC. Okay, stateless auto address configuration. Okay, SLAC. The next method is SLAC with stateless DHCP version 6. Okay, the third method is stateful DHCP version 6, meaning there's no slack involved in there. Okay, so I mentioned 3 flags earlier on. Now these are 3 methods. So how do we relate those flags? Okay, so for M flag is pointing to stateful. Okay, M flag is stateful. And then you have the A flag. Okay, A flag, you have slack only. Okay, that's the A flag. And then you have the O flag. O flag is pointing to this. Okay, slack with stateless DHCP version 6.7. So O basically means other. Okay, other information. So it will rely on slack to automatically generate its own address, but other information such as the default gateway address, the DNS address, the domain name, it will look for a DHCP version 6 server to provide other information such as this highlighted. Okay, so that's the O flag. M flag, that's managed addresses. Okay, that's stateful. Stateful DHCP version 6 will provide all of this. Okay, all of this. So with slack, you manually configure that. Okay, you give an IP address, IPv6 GUA address to the end device, and then you manually assign all of these others as well. With slack with stateless, you manually assign the network prefix and prefix length, but you query a DHCP version 6 server to provide other information. With stateful, there's no slack involved. The DHCP version 6 server has to provide everything. Okay, IP address, prefix length, including default gateway address, DNS address, domain name, etc. Okay, so you have a lab activity later on where you will learn a bit of this, how this is done. But this is also covered in CCNA 2. We look at this when we talk about DHCP version 6. Okay, so that's method 1, slack. I mentioned that earlier on. Slack allows the device to configure a GUA without services of a DHCP version 6. Okay, so key points you need to observe here. Devices, they obtain necessary information to configure a GUA. Okay, that's what's important. Okay, they don't worry about all the other information. So how do they automatically generate this address? Okay, because we see that slack is stateless auto address configuration. So notice something here. First of all, it comes down again to that IPv6 address. Remember, we learned that it's at 128-bit long and it's divided into 2 parts. You have the first 64 bits, you have the next 64 bits, and typically the first 64 bits is part of the prefix. Okay, so that identifies the network the particular device belongs to or is a part of. The rest of the 64-bit is for the host device. Okay, that represents the interface. Okay, so this is sometimes known as the interface ID. So prefix is one half, the other half is the interface ID. Okay, so with the use of slack, the prefix is provided by the router advertisements. That's this part. Okay, so the array message will provide what network the host device belongs to. But how does it create the other 64-bit? Okay, how does it create the other 64-bit? Well, this 64-bit is made up of 2 things. Okay, it can either be made up of the MAC address of the host device, or it can be a randomly generated 64-bit number. Okay, so it can either use an EUI64 or randomly generated method. Okay, so we'll see this in the next slide. Okay, hold on. So that's method 1. Okay, let's take a look at method number 2. Okay, so method number 2, we discussed this again in the first slide. With slack and stateless DHCP, array messages are used to provide the global unicast address but at the same time it will request that DHCP version 6 server has to provide other information. So Slack will be used to create its own IPv6 GUA, and the router LLA, which is the array source IPv6 address, will be used as a default gateway address, and then it will start querying a DHCP version 6 server to obtain other information such as DNS server address, including domain name as well. Okay, so remember that. Okay, that's a key thing. Okay, so here when you look at this, it's a good example. We have a router here that periodically sends out array messages. Okay, contained within those array messages, because this is an IPv6 enabled device, that array message will contain the IP address, global unicast address of this interface. Okay, now this is a DHCP enabled client device. Okay, it will start to send out RS messages to query any IPv6 enabled router for information. Okay, for information. Okay, now in the network there might be also DHCP version 6 servers available. Okay, now in that case the client can also solicit, or query or ask the stateless DHCP version 6 server for other information as well. Okay, so you can either have a server in place, or you could have a router doing the function of DHCP version 6 enabled router. The last method, stateful DHCP version 6, and it very clear here. You can see that stateful indicates that all information is provided. Okay, all information is provided by the DHCP version 6 server. So an array will instruct the device to use stateful DHCP version 6 only. Okay, so it will not ask you to generate its own GUA. Okay, the GUA will come from a list of addresses that's available on the DHCP version 6 server. It will also provide other necessary information like DNS server address, domain name, including. Okay, so three methods. It's best summarized here. Three methods: Slack with stateless DHCP version 6 server, and stateful DHCP version 6 server, which basically means no Slack. Okay, so here you have an M flag, here you have an O flag, and you have an A flag here. Okay, okay, let's look at the EUY64 process and how it's randomly generated. Okay, when you look at the EUY64 process, when the array message is either Slack or Slack with stateless DHCP version 6, the client is now required to generate its own interface ID. So when that happens, the client will now have to look at this part here. Okay, it will now have to consider this 64 bits. Okay, it will look at this and it will start to try and generate. Okay, now it can use two methods: the EUY64 process or randomly generating the address. Okay, so if the interface ID is created using the EUY64 process, this is generally what happens. Okay, so the IEEE defined the EUY, or the extended unique identifier, or modified EUY64 process purposely to allow the So the IEEE defined the extended unique identifier, or EUI, which is now known, or with the modified version now known as EUI64, for the purpose of allowing a host device to combine both its own MAC address with that of the IPv6 48-bit, the 64-bit address, to come up with a unique identifier for the client itself. That's why it's known as the extended unique identifier, or EUI. So you have a 16-bit value of FFFE, which is in hexadecimal, that's inserted into the middle of the MAC address, okay? The 48-bit MAC address, Ethernet MAC address of the client device. Okay, so what we're trying to see here is, remember, when the array message is sent from the router, if it's either Slack or Slack with stateless DHCP version 6, client is now required to generate its own interface ID. So how does it do that? It generates its own interface ID through this process, the EUI64 process. So it will take that 16-bit value of FFFE and it will place it in the middle of that 64 bits. Sorry, the 48-bit. Okay. So an example here is this. You have the 48-bit MAC address. Okay, remember every MAC address, every device has a unique hardware address or the MAC address. Okay, so that 16-bit value is placed right in the center. So if you count all the hex stats, okay, or if you count all the segments of the MAC address, you have 1, 2, 3, 4, 5, 6. Okay, there's 6. So notice right in between 47 and 75, you have the 16-bit inserted. Okay, 16-bit inserted, and you have this change to FE. Okay, so you have 99 same, 47 same. Okay, CE, E0, E0. Now generally the last the 7th bit of the client's MAC address is reversed from binary 0 to 1. Okay, so here's a good example given here. Okay, you have the 48-bit MAC address and the 16-bit is inserted right in the middle to come up with the interface ID. Okay, so that interface ID, when it's randomly generated, or sometimes it can be created using the EUI 64-bit 64 process. Okay, so when it's randomly generated, it depends upon the operating system. Sometimes the OS might decide to randomly generate the interface ID instead of using the MAC address and the EUI 64 process. Now beginning with Windows Vista, Windows uses a randomly generated interface ID instead of one created with EUI 64. So when you're doing this on the actual hardware, you will notice as soon as you bring up the Ethernet network interface card options and go to IPv6, it will randomly generate a unique identifier or extended unique identifier. The interface ID especially, it will randomly generate 1. Now because it's randomly generated, one of the things we need to ensure is that there's no duplication of address. So it uses a process known as DAD, or duplicate address detection. So whenever a device randomly generates its own interface ID, it will send out a message, okay, an ARP message asking, informing the other devices about its own address. If it doesn't receive any response or no reply, then it assumes that the address is unique and there's no duplicate existing on the network. Okay, so last concept, we look at dynamic addressing for IPv6 LLAs. Okay, so far we've talked about static addressing. We've talked about static addressing for GUAs, dynamic addressing for GUAs, static addressing for LLA. Now we're looking at dynamic addressing for IPv6 LLA as well. Okay, so when we look at link local addresses, okay, for the difference you will observe here is for IPv6, the LLA is a must, okay, is a must for every device. A device can still function without a GUA, can still communicate with the rest of the devices within the network. However, using an LLA, packets coming IPv6 packets cannot be routed. Okay, they will need a GUA. So given that LLA is a must for every IPv6 enabled interface, let's look at how does a device pick up and a logical link, a local link, address dynamically. Okay, so have a look at this figure here. Notice that the LLA is dynamically created using the FEA0, okay, /10 prefix, and then the interface ID as well using the EUI64 process, or it can use that as well as a randomly generated 64-bit number. Okay, so if you look at just to demonstrate this process here, if I go to that packet tracer file, you will notice that for the RA, okay, interface, we went ahead, let's do a show int G00. Okay, you will notice that for the link local address, we combine two things. Okay, we combine the two things that I mentioned here. Okay, we put together the FEA0. I'll just change this. We put together this FEA0, including the interface ID. Okay, so in the case where you have 2001, okay, example here, okay, in this case you have this 2001, and you have right at the end 1 : double colon, and then you have 1. Okay, that 1 represents the interface. Okay, that's the interface ID, the one here. Okay, so if you're going to use a LLA or randomly generate an LLA, dynamically assign an LLA, you combine FEA0 : and the interface ID, so FEA01. Okay, so you will notice we did that. Okay, when we were configuring the router, we went ahead and we typed int G00 IPv6 address FEA0 and 1. Okay, and then we specified this as a link local address. Okay, that's basically what we did. So this FEA0 represents the first 64 bits. Okay, and the rest of the 64 bit we used 1. Okay, notice this link local address was randomly generated. You see, FEA0 is still there, okay, but the rest of that interface ID was randomly generated. Okay, so that's basically what is meant by this point here. Okay, so dynamic LLAs on Windows, again, it depends on the operating system. OSs such as Windows, they will typically use the same method for both a select created GUA and a dynamically assigned LLA. So dynamic LLAs on Cisco routers, they will create an IPv6 LLA whenever a GUA is assigned to the interface. And we've seen this earlier on, that by default routers will use the EUI64 to generate the interface ID for all LLAs on any IPv6 enabled interface. Okay, so after you've completed lesson 2, after you've gone through your notes and you watch this video, you can complete the packet tracer file on configuring IPv6 addressing. That will help you to basically learn the different commands that are used to configure IPv6 address.